infrastructure never goes away, it just gets layered.
A new piece of infrastructure changes the way that you program computers and it changes the stack that's around it. We're building systems to build other systems.
Developers are making a lot of the decisions, and a lot of the marketing and sales to developers looks more like consumer these days than it used to.
Who is going to earn the distribution and earn sort of the developer attention is going to be a different game.
From an application standpoint, we've abdicated logic.
This is a pretty big deal. It's by far the biggest thing that I've seen happen sort of in my life.
Software was always the disruptor. One of the most exciting thing about the AI wave is like software is being disrupted. Like we're being disrupted, right? And so we're like
AI is disrupting software.
Right.
AI is eating software.
I know. We're like, ah.
Hey guys, we're here today to discuss the state of infra. We've done a consumer podcast, we've done a consumer team, we've done it with the AD team, now excited to do it with the infra team. First, can we get a definition of infra? Where does infra differ from enterprise? How do we think about it internally?
I would say infra is basically what makes software work, right? We'll probably get pretty deep into a set of technical definitions. You mentioned sort of networking, storage, compute. Where does AI fit into that? But I think at the simplest possible level, if you want software, infra is what engineers are using behind the scenes to make all this possible.
And our formal definition internally is technical buyer, right? So it's the stuff you use to build the stuff you use to build apps. And if it's used by a technical user, we consider it infrastructure, whereas something like, let's say, vertical SaaS could be used by a flooring company or by a marketer or by sales. That would not be considered infrastructure.
And technical user, for the record, is developer, data scientist, analyst, cybersecurity professional. Yeah, right. There's a, DevOps, right? There's a wide range of sort of like people. These are our people, right? Like the kind of nerds behind the scenes.
And in the system terms, you can think about it as compute, networking, and storage, but also all the tooling that goes around the developer's day of like what you're using to build software and what are the tools and products that are operating these ever-growing, more complex software as well, all the way to semi-technical users that may want to, either prototype or tinker with building applications. We're very interested in anything in the technical domain and used by technical people.
So you mentioned compute, networking, storage. How should we think about models? Is this the fourth layer of infra? How do they interface? How should we think about that?
I certainly think of it as a fourth layer of infrastructure. It's, it certainly leverage and build on top of all the three pillars we're talking about. It has a lot of demand of compute, and of course, it's trained and also producing a large amount of data. And to leverage and use these models for our purposes, latency and networking capabilities is also very important. But it's going to be as prevalent, as any piece of infrastructure software. I don't know, like the analogy these days anymore. Is it a database? Is it sort of like a new form of compute? So really, to me, it's like a fourth pillar that incorporates everything, but also provides intelligence for the software we're using and building today.
I think it's probably worth asking like why a piece of infrastructure is a piece of infrastructure. Yeah. And generally a new piece of infrastructure changes the way that you program computers and it changes the stack that's around it. Like it's got different memory requirements. It's got different latency requirements. And so it just requires rethinking how we build software and how we build infrastructure. I would say in addition to compute, networking, and storage, I would say distributed systems would also be included just because like things like state consistency require you to think about like proximity and guarantees. I would say databases probably did too because it changed our programming model. You have different guarantees. And these models very much fit in that for a couple of reasons. I think Jennifer's exactly right. Like you just build different data centers and different chips if you want to build these models. So it has that impact. But programming them is like non-obvious. Like we're just still trying to grapple like how you program them. Like they don't really listen to you. Sometimes they do the coding themselves. And if I were to try and distill like, what is the one biggest difference that these models provide to infrastructure? It's the following. I don't remember ever in like the history of computer science where we've like, from an application standpoint, we've abdicated logic. Like actual, like application, like in the past, we've abdicated resources. Like you're like, give me compute, give me storage, like, these abstracted resources, but the logic, the yes or no, like the what it's doing always came from the programmer. But in these ones, we're like, come up with the answer for me. And so it's requiring us to rethink, what does it mean to be a programmer? What does it mean to be software, et cetera? So it's clearly very fundamental to computer science. And I would say, again, to Jennifer's point, is very, very much a new piece of infrastructure.
And I think a lot of people are trying to reason by analogy. You sort of alluded to this, Jennifer. It's like, oh, is it like a database because it can answer queries? Or is it like a network because it's sort of non-deterministic and we need to handle retries and weird edge cases? But like, I think people are really just trying to figure out how to program these things, which you sort of said, Martin. But like, we've kind of got to start from a blank sheet of paper, which is what makes our jobs like really exciting right now, because there's a lot of people trying to figure it out and coming up with new ideas.
I have to add on. So listen, many of us have been in computer science for a long time, right? We've been in our schools and in our, operating lives and in our investing lives. And like, software was always the disruptor, right? Like we disrupt, we disrupt the taxis, or we disrupt like sales, or we disrupt the back office, or we disrupt everything. Like, one of the most exciting thing about the AI wave is like software is being disrupted. Like, we're being disrupted, right? And
yes,
so like,
it's disrupting software.
That's right.
It's eating software.
I know. We're like, so we have to think
software
about
is a self-eating.
Yeah,
ice cream.
that's right. It's like, honestly, I think this is the first time I could honestly say that like the profession that I've dedicated my entire life to is being disruptive, and it's very exciting because it's kind of eating itself in a way.
And it's tempting to be a curmudgeon, right? Because we've all been doing this our whole lives. So it's like really being open to and embracing the new 100%. Stuff is like the key thing.
What still applies is infrastructure never goes away, it just gets layered. In this case, it's definitely, all the infrastructure that we've been using and leveraging in the past are still very relevant, but it's definitely getting layered by having this fourth pillar, which is AI and models.
What's different from past super cycles versus what can we learn as we enter this new one?
There's two things that happen. So one of them is often when you bring the marginal cost of something down, like with compute, we did it for computation, and for the internet, we did it with distribution. It increases the TAM a whole bunch. So for one, you almost always see this massive TAM expansion. And part of that tends to be because the TAM is bigger, you've got new users. And because you have new users, like there's normally like a new behavior that happens, right? Like this is very much the case with the internet, right? Which is like people weren't used to going to a computer and talking to everybody around the world on top of the internet. And existing companies don't know really how to think about new behaviors. Like they've built these sales motions and the operating things around like the old behavior. And so you see TAM expansion, you see new behaviors. Those new behaviors provide white space for challengers, new like startup companies to come and to go ahead and fill those models. And I think we're seeing exactly that happen with this one as well. Like clearly this market is massive if you look at how successful these model companies are, but also you're seeing use cases that like computers just never really have done before. And you're seeing that too. And so in that way, I think it rhymes very much with say the internet, and it rhymes very much with probably even the microchip.
Maybe I'll answer that question just from my personal experience. I'm always like sort of a tools person, and also wanting to like having tools fulfilling certain creativity, because I kind of came to coding and computer science as a late bloomer after, my 20s, and it really enjoyed all the tools available for me at that point of just like, building software and like learning computer science as well. Now we just have like, massive leverage in trying to create anything as long as you have a good idea. Like going from Martin laughs at me about this. Like I was a bigger like low-code, no-code champion for let's say the last 5-10 years, because again, these are tools for people who have good ideas but may not be like educated in the computer science term. But the retools of the world, the Wix and Squarespaces, like you can build applications, can build software easily with these tools. But now you're given like the next level of thought partners, tools to really, as any role in the company, prototype, software interfaces for your end customer, for your end user, as long as you know what they need, what they want to see. Like you can really realize these ideas really quickly in like at your fingertips.
So low code's finally happening. It just takes a lot of code.
It just turns out the code is natural language,
I know, it's so funny because when Jennifer joined the team, she was very excited about low code. But from my view, low code is like Python. It's like a scripting language, like you write
interpreted languages.
Yeah. And PM is low code. You're right. So we kind of had to bridge that gap, and it was kind of in a way like a bit irreconcilable, like until AI came out, and it's very, very clearly like what the promise of low code was. And so you're right. I mean, it really is disrupting software.
So when I was a kid, right, the internet was sort of a new thing. I just remember really vividly. There was this movie with Sandra Bullock called The Net, and she orders a pizza from her computer.
Yeah.
And this was like completely mind-blowing.
Yeah,
and like now, actually, this is a common user behavior, but like what we're dealing with now is just so much bigger than that, right? I just think it's really hard to, like I think some of these points about how will the infrastructure evolve, like how will the companies adapt and things like that are probably transferable. But this is a pretty big deal. It's by far the biggest thing that I've seen happen in my life.
Yeah.
Let's zoom out and take this long view. And Martina, you're actually the perfect full circle because weren't you the first infra investment ever as a portfolio founder?
I think it was either me or Okta, but I will say I was like, me and Todd were like the infra portfolio for like Fund 1 LP days when they would trot us out, in front of the LPs. It was like me and Todd from Okta. So for sure, I was one of the first two.
And then you started up, or was sort of one of the leaders of the infra fund. At what point did we develop a clear infra practice at Agency?
So we always had strong infra people, right? So like Ben Horowitz is an infra guy, even, and honestly, I would say Mark is like, he kind of, masquerades as a consumer guy, but he's actually like revolutionized the way we use computers in this deep infrastructure way. And by the way, many things came from that, JavaScript, etc. We had Peter Levine, ZenSource, we had Scott Weiss. And so like, there's always been deep infra, but when I joined the firm, we didn't think of it as infra, we thought of it as enterprise. Right. And so, you're either in the consumer team, you're in the fintech team, or you're in the enterprise team. And the thing about just classifying this stuff as enterprise, the go-to-market motions for something that touches technology and being able to reason about that is so different than reasoning to the go-to-market motion that's purely through like sales, right? So, and we've just learned over time that like we do deep market diligence as a firm, and we do deep diligence on companies before we invest in them. And that the type of diligence we do if it was deep infrastructure just required a different, type of junior partner and type of analysis. Over time, we realized that like companies where you can evaluate more by like the business model, the market buyer, the unit economics is a bit, those kind of class of companies are just sufficiently distinct. So we decided to just pull them apart. And then that's why we have the apps fund. Yeah. And then of course, the infra fund.
If you think about, enterprise, there is, of course, the horizontal piece of it, but also a lot of vertical enterprise, whether applications, buyers, sectors, where infrastructure is almost always horizontal. And that's another, thing we realized along the way of like, we still want to like appeal to these like technical audience and technical buyers, but we want to think about sort of the space in a horizontal fashion where these technology can be distributed to like all these different sectors and verticals as well. And it impacts how we think about, the stack. It impacts how we think about what is going to drive sort of the form of like how the stacks integrate with each other. It just like kind of different from how enterprise generally.
So it's actually a very, very important distinction. I'm glad you brought it up. So like technical buyers tend to be centralized buyers in a way, right? Like IT will buy compute, network, and storage. And yes, you've got the compute person and the networking person, but it kind of rolls up to IT. And developers are kind of a centralized buyer. So like you can understand IT and you can understand the developers. But when I was looking at vertical SaaS apps, early in my investing career, to understand how to sell into a flooring company, you have to understand the flooring market. And that's entirely different than like the pet food market. And that's entirely different than the construction market. And so I felt like there was no real central software buyer for these kind of verticals. So as you get further away from core infrastructure, you get away from this notion of a centralized educated buyer, and just the level of analysis becomes very different. I think that's exactly right.
Well, and there's even sort of like the horseshoe theory of software buyers happening now, where you have like consumers over here, and then you kind of work up to like apps. And like you would think that like infra is way over here, but it's actually kind of bending back around. Like developers are making a lot of the decisions, and a lot of the like marketing and sales to developers looks more like consumer these days than it used to.
Yeah. That's an incredibly important point. I was, researching the stats the other day. Like when I first joined, venture, or maybe even just started thinking about infrastructure, developers still like in the low tens of millions, and they were becoming like the next generation of consumers. Now they're definitely the next generation of consumers. It's going above 50 million, on the way to even bigger than that. Now we're talking about natural language being the programming language for everybody. Like they're making decisions just as a consumer. So we're of course like training ourselves to also understand how developers as individuals individuals adopt tools, but also like IT buying centers as customers and enterprise organizations like evaluating tools. So there's just, a lot to learn and figure out, given these are the technical audience we really care about.
Yeah. I want to get to where we think about how we think about our investable universe and what sort of subcategories are mature versus newer or sort of ripe. But before that, I want to better kind of trace the evolution a little bit. So maybe, Martin, we could start with you. If you had to kind of categorize, like, since you've been investing, like the different waves of infra invest, or like maybe the different inflection points at which it kind of changed how we even thought about it.
Totally.
How would you characterize it?
Let's just say for like just like the life cycle of the firm. So we started 2009, and that was actually kind of pre-cloud. And so a lot of the early investments were right on the cusp of cloud. And like, for example, my company, like the cloud was out there, but it wasn't sufficiently deployed. You could use it as kind of a core thesis. And a lot of the early investments were like this. And we talk about it in terms of tech, but it rips through the entire business model. Like, early software was on-prem with a perpetual license. That's just different economics and different analysis, right? And so like the pre-cloud, installable software area was one. And then we saw the cloud transition, right? So we went to like recurring revenue, totally different deploying model, totally different operating model. And during that time, we'd see things like, net dollar retention being more important, expansion being more important, gross churn being more important,
gross margin
being more important. Like, everything changed to that. And then, and by the way, meanwhile, of course, we saw consumer being disrupted by mobile, right? With the rise of like the Ubers and the Lyfts, and the Airbnbs. And then again, we're seeing it happen again, during this AI, which I would say the AI transformation of the last 3 years has been the most dramatic I've seen in the last 30 years of being in this industry. And there's one interesting blip along that path, which is COVID. Which is like we're all like, we come from the realm of like enterprise sales and like being on the ground and like deploying things, and like that totally evaporated. So like actually that was kind of a dramatic shift as well, but it was driven by this kind of force majeure as opposed to a secular technical wave like the other two did.
I would say one of the benefits COVID brought is there was already the trend going of like developers buying and adopting tools, like this bottom-up motion for infrastructure and for dev tools. It kind of got accelerated during the COVID time, where lots of people just like tinkering, trying out products and tools, and also more people building dev tools during that time. I feel like there was a flourishing ecosystem just of these like PLG or product-led dev tool companies that are giving birth to now we're seeing a lot of like AI dev tools that are coming up.
There's nothing developers like better than being forced to stay home
and
not interact with other people and write code, right? This is like,
best news ever.
That's amazing. Okay, now that's a good overview. Let's go deeper into the present a little bit. Can you guys share how we think about sort of the different subcategories or landscape that kind of makes up infra? And we could also plug some examples of portfolio companies or spaces where we made some bets.
Here's a few important categories. Developer tools, meaning anything developers use to make their lives better, easier, faster, more efficient. Cursor is probably our top developer tool company right now. But we've done a bunch.
And before that, GitHub, right?
GitHub before that. And Jennifer, you've actually backed a bunch of interesting dev tools companies in the last few years too.
Yeah, from Linify, Stainless.
And there was a long time where the dev tools was kind of like written off by VCs, right? Like they were
the TAM was too small.
Yeah, exactly.
Yeah. I mean, at the time of GitHub, would you ever have imagined a repository would be a huge company?
Right.
Like, it was like almost a joke. Yeah.
Right. And people were unsure about the business model and all these things.
Small TAM is the classic like red flag for infra investing. Like if you're at home listening to this and someone tells you small TAM, like run in the other direction.
They're not an infra investor. Infra
creates
creates TAM. If there's one takeaway from this thing is TAM creative. So like I think dev tools, you've got core infra, which is compute, network, and storage, right? This is like to IT. And then you tend to actually be quite a bit above the core infra stack. So maybe you talk through kind of the areas you focus on.
Well, I think about both, like how developers are like using tools to improve their efficiency, but also how customers are getting value out of that as well. So a lot of, packaging maybe dev tools into SaaS forms. Like I'm invested in this company called Pylon. It is a SaaS company that does like, customer support, but fundamentally it's like building a data pipeline. So that's like core infrastructure that's very good at connecting with systems and providing context to a lot of like agents and AI models. So to me, that's infrastructure. And we're spending a lot of time on, of course, like the cutting edge AI research. So a lot of foundation model investing.
I will say the reason that we're a little bit skittish on this question is early in super cycles, it's very hard to distinguish between an infra company and like the application companies. And the reason is because the TAM is so small and so new, the new technology becomes the app, right?
Right.
So let me refer to the original super cycle that started the firm, which is the internet. Like Netscape, I remember it when it came out. Like it was like a consumer thing, or at least a student in school thing, right? And so this is one company which, everybody was downloading from an FTP server, Netscape, and using it as individuals. The enterprise didn't know what to think about it and banned it or whatever. And the same company that was like built JavaScript, that's building this core technology, is also doing the browser. And over time, it kind of matures. And then, of course, you have all of these internet companies and then all the applications show up. We're seeing the same thing in the AI wave. Like, is Midjourney, is that an infra company? They build a model, or is that an app company? Well, it's kind of both in this sense. And so I do think that at this stage, it's very hard to distinguish.
Right. It's exactly right. Like it's very hard to answer if OpenAI is an app company or it's an infra company. It's literally is building like infrastructure that's like a cloud running these models for different sector and different use cases, but at the same time building a consumer app that's ChatGPT. So we think of foundation model companies are similar, like 11 Labs, they're a voice AI provider and they have the creator application that can use the studio to create voices. But at the same time, they're also supplying the voices to these large scale enterprise use case that are like, fine tuning, cloning your own voice and, distributing that through API. So it's sort of, both.
Another area we've done a lot of work is data systems. And there's sort of been these two branches. One is kind of this back-end data eng driven big data systems, Spark, Hadoop sort of thing. And the other is this sort of data analyst, kind of more tabular Snowflake kind of thing. And I think as a firm, we've been super, super active and super aggressive, invested in companies like Databricks, I mentioned, Fivetran, DBT, which you guys invested in together, Hex, which is doing really, really well, Tabular, which was acquired by Databricks. So we're still, I think, really, really bullish on this. Unfortunately, AI has kind of sucked the air out of the room for a lot of data companies from a bunch of different angles, but I think we'll continue to do more of this a lot as well.
How do we think about defensibility for AI companies, whether it's an app at the app layer or the model layer? Do they all have their respective sort of areas of defensibility, or how has sort of our notion of defensibility evolved?
So we once wrote a blog post that there was no defensibility anywhere in the stack
for anything. For anything. And yet people make lots of money.
Right. The argument at the time was like, okay, like NVIDIA has sort of a moat because chip designs are hard to copy. But if you go sort of up or down, they're all sort of manufactured at the same place, right? At TSMC. If you go down, if you go up, the cloud providers provide effectively the same product. Like the models are training on the same data, have like similar capabilities. The apps are all kind of like all using the same model. So that was sort of the naive theory, I think, when we were just trying to understand this at the beginning. And I think maybe it was true at the time. What Martin was sort of alluding to a second ago is like, meanwhile, every company at every layer of the stack is doing like fantastically well right now. And during this kind of initial phase of industry development, which we sometimes call the Brownian motion phase, like I actually think it's really hard to make sort of pronouncements like this about what's going to work, what's not going to work, where's value going to accrue, et cetera, et cetera. It's like app companies are doing really, really well. And like, we're like pretty clear past the sort of wrapper phase. Like, I don't think there are any wrappers anymore. Like building good products with AI is really hard. Yeah. And the founders doing it now have like really good kind of intuition for how to do it. Yeah. The models are clearly like pushing the whole industry forward and like they've built huge companies so it's like, it's kind of all working right now. And I think you could actually make a case for how defensibility will work. It's quite different from the way defensibility has worked before. So, and maybe you guys want to add on to that.
Yeah. On how defensibility worked for infra companies before, largely like it came from, it's really hard to, let's say, if you're building like a new database, like a new framework. It just takes a lot of expertise in the domain of understanding, what has happened in the past, where did the field come through, and what are the, innovations that needs to happen to polish, let's say, like a software into this new abstraction to provide to developers. Maybe one example I'm thinking of is like DuckDB. It's such a high performance, small, but really nimble database that it took like 4 years for the team to write it. To replicate that is really hard. And that's generally what happened in the past infrastructure space. Is like it takes these experts a lot of time to build like a new piece of security software, if it's like, YubiKeys, or if it's again like Databricks on Spark. But now as the AI infrastructure come through, like I think a lot of those defensibility still stays and still are true, because these are earned secrets of like what are the downfalls and guarantees other software run into. But I do feel like the adoption phase is just like really massive. Like who is going to earn the distribution and earn sort of the developer attention is going to be a different game.
The industry tends to go through these expansion and contraction phases. Think of like the Big Bang or something. Like it expands and then it contracts. So what happens when it expands? When it expands, zero-sum thinking is deadly because you just getting more market. We're clearly in an expanse phase, right? Like everybody is like, oh, NVIDIA can't sell more chips, but they keep selling more chips. Oh, like the hosting platforms can't continue to get margins, yet they keep continuing to get margins. I mean, Matt said it perfectly. I totally agree. So if you're in the expansion phase, then there's just more to sell. You should be aggressive investing. So what happens in the collapse phase? So look at any layer of the stack. So in the collapse phase, which things start to consolidate again, you have consolidation. But what is the end state of consolidation? The end state of consolidation will always be an oligopoly or a monopoly. It's not like layers ever go away. If you have an oligopoly, like say the clouds, then you have which is effectively price fixing, but it's tacit, right? Which is everybody is like, we're going to price at this and we're going to maintain our 30% margins. So you still have value there. You have margins. Or in the case of like a monopoly, you'll end up with like, say, like an Intel at the time, then you can also maintain margins. So in none of this do you lose margins. Right? And I just think this is why people think so sloppy about this. People use the words like commoditization and no defensibility. That tends to be a battle between layers of the stack. But the only way you can do that is actually move down the stack and enter somebody else's layer, which is incredibly hard to do. And you do see it. Like, so of course, Google is going to build their own chips and they start moving down the stack. But that's a very, very different layer than somehow Google playing the different layers off against each other. And so I would encourage anybody that does invest at least in infrastructure to not think zero sum and to realize that historically every layer of the stack has maintained some level of value and margin. And if not, it was because a layer above them managed to kind of verticalize themselves. But then it's that one player against the rest of the world.
Yeah, I mean, it's like faster than light speed travel has just been invented, right? Yeah. And we're sending all the spaceships out in all directions, and there's plenty of planets like and stars to claim for everybody. Like we don't need, we're not even close enough to each other to like fight
for the AI wave. Yeah, for sure. Yeah. Like this is exciting, but it will slow down, and then the consolidation will happen. But I guarantee you'll just end up with these great companies that maintain margin, like. AWS still has great margins. Google still has great margins.
Databricks too is growing at incredible speed for their
scale.
Yeah. I think people underestimate how hard these problems are in many cases, right? You're sort of applying consumer thinking because this is how we live most of our lives. It's like, oh, wouldn't it be relatively easy to move to a different part of the stack or take out your competitor or a customer could just switch back and forth. And and it's just different laws of physics, I think in infra.
Totally it just agree. Turns out in general, the switching cost of the infrastructure piece is so much higher. Even with like API business, people tend to think you can just like switch over to another API. There's so much logic embedded in calling the API in the software itself. Like there's a lot more switching costs compared to, your regular SaaS software consumer.
Yeah,
software.
Totally, because you're actually integrating systems, right? It's not necessarily a person who can just have a preference for one thing or another. You're sort of integrating. Yeah.
For sure.
Sam Altman once had the advice to startups last year. He was like, if you're worried about us improving our models, you're in a tough spot. But if you get more excited about your business by us sort of improving our models, then you're in a good spot. Do you think that's a helpful framework or?
I think it's helpful for OpenAI for people to believe that.
No comments.
I want to say that too. Like, if, A16Z, if you think us investing in this company isn't good for you, then but like, if you want to buy from our companies, like, that's great. I mean, that's a very open question. That's actually a technical question. It isn't a business question, which is how much does general training generalize, right? So we know in like the pre-training world, it generalized really well. So you'd create one model and that model was just as good at code as it was at like writing a poem right? So we know that it was very general. And in that world, sure, as the models get more powerful, then they can do all of the things, so they compete with all of the things, right? But it seems clear to me, and again, this is an observation and it may not be correct, that as we get more into the RL world, that you make some trade-offs. And then let's say I RL something for code, it's not going to be as good as something else. And like, you're making these trade-offs. And in that world, then it's not the case that the model is going to generally be good. So I think it's great to compete at the model layer. And so again, I think this is maybe a reasonable rubric, certainly for OpenAI to have people believe, maybe a reasonable rubric if you believe that these models are going to be generally great, but I just don't think it holds up to how things are going to play out.
This was a debate we had 2 years ago, I think, whether the general model and the most capable model will rule, or a lot of small, medium-sized models that are very good at specific tasks. That's going to be the future. It turns out both are true.
Both, yeah.
When we're talking about complex systems, you cannot just like use one model that drives everything, at least not today. But you can compose like, very capable and powerful models to like, take certain tasks and also chain together, processes from like processing document to like feeding in a model to have some reasoning and give you back clean and structured data to make decisions and put into your application to serve end users. Like, that's a complex system that invokes many model calls instead of just like one big model's task.
Did you guys have any reactions, or is it worth talking at all about Karpathy's talk? Did that framing resonate with you? Did you have any sort of differences of how you would frame certain things, or how you'd predict? One thing he mentioned is that he thinks it's not the year of agents, but the decade of agents. Perhaps it's not as immediately, upcoming as we might have thought.
So there's this idea of prompt engineering that people have talked about. And somebody, it wasn't Karpathy, but Karpathy piled on top, is this, it's really not about prompt engineering, it's context engineering. And so what is context engineering? So if you're going to call a model, you kind of have to know what to put in the context in that prompt. And what tools do you have to do that? Well, you could use other models, but at some point you're probably going to use traditional computer science. You're going to use like things like indexes. You're going to have to do prioritization, et cetera. And to really drive the best performance out of those models, you do want the context to be correct. And I do think it's probably the right framing of this problem. And the next step is in as much as we're going to provide formalism to how to use these models, to how to use existing tools, to how do you improve the performance, you should be thinking about what's the right way to get the right context into those models. And I bring this up because, like we said before, new infrastructure pieces create new patterns and new methods of software and building systems. And this is a great example of that kind of emerging before our eyes and people reasoning about it. And I truly believe in 5 years, we'll look back, we'll come up with a whole new, set of formal ways to build software, and they will have strong guarantees and we'll understand them, and, there'll be all the tools for it, et cetera.
The way I think that relates to our world is if you think about what is the new form factor of infrastructure that needs to become part of this context engineering, it goes back to, a lot of what we're obsessed about it with data pipeline. How do you feed the right data and context into the models or into the context, and how do you have agents use tools or the infrastructure that will provide a discovery and, guarantees of observability of these tools as well. Like, it's the classic infrastructure problem that's still unsolved. So it's a very exciting time.
There's a few different types of infra founders, right? And we could probably come up, there's the sort of infra founder who loves solving really messy, long tail, kind of like nasty problems, right? There's a type that kind of just gets fed up with a problem and they're like, I'm going to solve this finally, like I'm sick of this. Then there's the type that just kind of sees the world in a new way, right? And it's kind of like, this is actually how we should marshal these resources. And like, they can change how, like React is a great example of this. We had all these like kind of progression of front-end development frameworks, and finally React kind of was like the way that stuck, and for years now it's been sort of the default front end. So like, I think what Karpathy's talking about is kind of trying to figure that out, right? And I think his software 2.0 thing was really interesting. We were investing in a bunch of like traditional ML companies at the time. And I think software 3.0, I think he's sort of right about that too, in sort of directionally. And I think my hope is it'll inspire a lot of new infra founders to kind of do this work, like see the world in a new way and like figure out how these primitives should really be kind of arranged.
One of the difficulties of having any conversation around AI is it just exploits this weakness in the human imagination to like dump all of our fears and hopes and dreams into this anthropomorphic fallacy, right? It's just, and this goes all the way back to the Promethean legend. And so, I mean, let's talk about even this context, right? Like, you know, we're building systems to build other systems. Those systems have constraints, right? And so you can fail on either side of this when it comes to this anthropomorphic fallacy. On one side, you can be like, this stuff doesn't work, you shouldn't use it, you should only use traditional things, which, okay, that's clearly not the case. It seems very useful. But on the other side, you can kind of like, you know, believe they'll solve all of our problems and you don't need formalism and you just kind of like go to the beach and you come back when AGI is done and it'll do it for you type thing. And so part of our job and what we spend a lot of time talking about is trying to find that pragmatic, non-blinkered, non-pessimistic middle, despite all of the rhetoric. And then you hear all the rhetoric, right? The stuff is going to like, you know, no, we're not going to have to work and we're all going to be on
the beach.
Right. Or, you know, like it'll kill us. I mean, you know, the whole thing. And I think where we've landed is this is a real disruption. It's just changing all of software. It'll look something place different. But it is still going to require professionals. And I do think that like the statement it'll require professionals is a very meaningful one. It means that you actually still need people that understand the specifications of the systems. And not everybody agrees with that. Some people are out there like, listen, you will never need a programmer again because people are beginning to just say some high level thing and it'll show up. And the only one statement I'll say to that is formal systems came out of natural languages for a reason. And like either you care about specifying what you're designing or you don't. And if you do, you need to be a professional. And that's why every professional discipline, even though they started with a formal or a natural language, has ended up with a formal system.
And what is your mental model on coding specifically? Will there be like fewer engineers who are just higher powered or sort of whether fewer junior engineers? How should we think about?
I think the best way to think about this is simply that we're going to have more developers. I think it's very unlikely that like we're going to shrink development teams because we have amazing new tools. Like that's just kind of not how these markets have worked in the past. I think exactly the opposite is going to happen. Is like we're going to be creating so much great software and it's going to be so accessible to so many people who may work at a big company or may just be sort of hacking on the weekend. You can't anthropomorphize these models, right? A model is a file on a hard drive in a computer somewhere. And when you run a Python script, you can transform one piece of data into another piece of data like that. That's what this is. And programmers, you know, programming is a fundamentally creative job, right? You are literally creating things in the most strict sense of the word, which is you're creating software that doesn't exist before. And that's something only a person can actually do at some level of abstraction. So I personally think this is a huge boon for programmers, and you have to change the way that you're working, and it's like a huge productivity boost. And I think that's like more, it creates more, not less.
I cannot agree more. I feel like for many of the developers and programmers I talked to today, they're like going to Disneyland just because how many great tools there are to help them move faster, like, you know, build things they have always wanted to on as both side projects and also their main job. I do think it also changes the dynamic of like how people are picking up new languages, picking up new frameworks. It is, again, sort of a next level of iteration speed, given what we're seeing with AI agents and also AI coding tools.
Here's another, I think, useful mental model on this stuff. Like, I think it's worth asking the question, why do people buy software? Like, why does someone buy some random SaaS tool? Is it because it's so hard to build it? No. I mean, like, most SaaS tools are like CRUD. Like, they're just these basic kind of read-write databases. They're all kind of the same. So why do people buy them? And Aaron Levy, who's the CEO of Box, I think said this so beautifully. the reason people buy software is because somebody else made the decisions of what the workflow should be and what the operational logic should be and what data is important, how you use that data is important. Like creating a product is a lot of understanding what is being used and guiding the user along that direction. So if not, I'll just give you a compiler. Like you do whatever you want, or I'll just give you a database and you do whatever you want. I mean, there's a reason that we have a proliferation of vertical SaaS, and it is this kind of this articulation or, you know, this transfer of domain understanding. And that just doesn't go away independent of how you create the software. And so we will still need to design products based on whatever problem is being solved, guide people so that they're the most effective with them and they can understand the best. And you know, we did this with assembly before, and then we did it with high-level languages, and then we did it with high-level frameworks, and then we're going to do it with AI. But like the fundamental process of that articulation will not go away.
And it's totally orthogonal to creating the software itself, right? It turns out to be a much harder problem to go out and collect requirements from an unknown set of users with an unknown set of needs, and like figuring out what to build. That turns out to be much harder than actually building it.
So what do you think is the average number of lines changed in a PR in the industry?
2.
Yeah. But it shows you to the point. Like it literally is understanding the need from the business and the need from the user and making some minor tweak. That is the long tail that goes into software. And by the way, it turns out it's 2. Like,
oh, really?
Well, I think it's the median. It's the median is 2. Yeah. So
I've written a lot of, like cheap PRs in my life. Just for the record, by the way, Martin said CRUD. CRUD is a technical term, right? Create, read, update, delete. We actually think applications are great, right? We don't think they're CRUD-y. They just like literally are CRUD.
CRUD is a
just footnote.
Good to know. The Jennifer, you were mentioning earlier how 2 years ago we were having this debate on generalization, and we've learned from it. What are the debates we're having now internally or with your peers, or what are the main questions that we're asking that we can't wait to see how they're going to reveal themselves in the next few months or next year that are going to impact our business?
Oh gosh, every week is different. What are some recent ones? Definitely like how realistic are agents today, like really producing production level software? I mean, that's more on the coding agent side, but also in general, like the agent evolution. Where are we in going from demoware to producing real value, tangible value?
Synthetic data is one we talk about a lot.
We've been talking about it for 10 years.
Yeah, I mean, this is what's so great about infra. You can have the same debates for 10 years and they never quite go away.
It's like change the background. It's like everything else.
Yeah, consistency versus availability. Literally every system has this trade-off.
Yeah.
So the synthetic data thing, right, is like it's almost an information theory question. It's like, can you make models meaningfully better without introducing new information to the system? And I think it's now pretty clear you can do a little bit. But the question is, like, does this lead to sort of like a self-improving utopia of models or not? And I think we have some pretty strong opinions on the not side of that. Generalization, Martin mentioned, is a pretty interesting one. Like, if you train a model to be really good at math, does that mean it's going to be really good at other things? Or is it just like really good at math, which I get excited about? Not everybody gets excited about this.
Another one that we talk a lot about is like what these things are actually good for. Just because the path we came from used a lot of AI, pre-gen AI used a lot of AI. So there's a lot of AI-shaped holes in the enterprise, like chatbots and this and that. And like that's very much on the brain. And it seems to sometimes confuse the discussions from the new use cases we're seeing. Like if you look at the most common use cases of something like ChatGPT, I think the top one is like companionship and therapy, and then it's like managing my schedule, and it's like the top of the pyramid of need stuff. And then number 5 is professional development, not like low code development or whatever. And so I think what is happening is we have this idea of what we thought AI was going to do, and like, just kind of the stilted attempts previously. I mean, like Jennifer actually, ran product for a chat company prior, and then what it really is good for. And clearly there's some overlap and convergence, but it's not nearly as big as people say. And so we do spend a lot of time just trying to be very honest with ourselves, or like, what is the new behavior being created? Where is this stuff getting used? Like, what is it just being trying to cram into places it's not actually quite good at?
To that point, how do we think about agents right now? Or what are they good for, going to be good for soon enough? What is sort of the state of them? How do we think about the broader conversation?
I mean, coding agents are awesome. Like they're amazing.
It's really amazing. So I have a very simple way to think about this. And I'm like the anti-agent guy, by the way. I think it's kind of a marketing thing. This is the other thing about infra people. We are allergic to marketing, which is not always a good thing. Which is a good thing you're here, Erik.
Yeah.
To help
Oh,
us.
that's what do you mean?
Yeah, exactly.
Agent.
Yeah, can you explain? If you take the simplest definition, that is basically an agent is an LLM running in a loop. A very simple way to think about this is errors propagate throughout the loop, right? So if you have a small error, it gets worse and worse. And this is why a lot of agents doing, say, general web browsing don't perform very well yet. On the flip side, if you have a way to correct those errors in the loop, which is one thing that you have in code, right? You can lint, you can interpret, you can even try to compile and things like that. You actually do see good performance over time. So that's a very simplistic and maybe not quite the right way to look at it. But if you can do this kind of error correction, I think you're seeing a lot of sort of improvement from this iterative approach.
I mean, it's incredible. I'm actually on the GitHub mailing list of a lot of the companies that I work with. I mean, just mostly for interest. And I have, even in the last week, seen a bunch of kind of cursor agent commits, and even in the last 24 hours, the Slack integration, seeing it come from Slack. And so I do think for kind of bite-sized, well-articulated tasks you can articulate very well, we're starting to see them really work. So in the coding space, I would say I'm a convert. But to Matt's point, go wander out in the woods and bring back a bear. I think we're a ways from
There are a lot of errors you could run into in that instruction.
Will we see more vertical integration or more horizontal specialization?
Historically, we've seen both. And what's interesting is we're already seeing both now, right? Apple, of course, has just been historically vertically integrated.
Yeah.
Microsoft and Intel, historically horizontally. And often companies will start horizontal and then go vertical. So Google was horizontal. I mean, it was built on top of normal servers, but then they built their servers, and then they built their own chips, they built their own networking gear. And so I think you always get a mix of the two. What's interesting about now is we're actually really seeing both. I mean, I would say that OpenAI is very much a vertically integrated company now with ChatGPT driving a lot of it. I would say Anthropic, a lot of the usage really is more horizontal, and they're doing a great job of that. I think we're seeing this on the model layer too. I mean, a very interesting discussion we haven't had, but it's a very interesting one, is open source, quote unquote, really seems to work with these models, just because you can't, as a user, recreate it. So if you look at BFL, they've done a great job building kind of a horizontal layer for these models. But then you've got companies like Ideogram, which have built a great kind of vertical experience as well. And so I would say for AI, we've got already this early on great examples of both. And I don't see any reason that will change.
I think from the business front, it just poses new interesting questions and challenges too of how do you capture the value. Of course, horizontally can capture the value through being able to address every single use case by providing that to developers or enterprises. But if you vertically integrate, you kind of have to pick the lane of do I want to focus on image model side? Do I want to focus on, graphic designers? Do I want to focus on, people who are generating photographies? You kind of have to understand the market and the user personas, use cases pretty well to capture the maximum value, where you probably can, take a easier path to just provide APIs so everybody can use it.